of the number of mouths that we need to feed, it is going to be an additional 3 billion. And also the number of people who are going to be engaged as a person in the agricultural sector is actually statistically dropping. So all of this brings us to the point where the amalgamation of technology as well as agriculture is inevitable. That is why interventions such as IoT and artificial intelligence is of the need in the field of agriculture. In terms of the overall agricultural value chain, if you look at where all intersections of technology and IoT could actually happen, it is almost each segment that we are looking at, all the way from inputs, production, farming, harvesting, to the food processing and the customer. So you can say all the way from the soil or the seed, the fork, or the farm to the fork, as they call it, interventions in terms of technology and IoT is need. There are various use cases that could be done in terms of whether it is scarcity of resources that you see or scope of improving yields, resource management that could happen in this segment, to this segment where there is high amount of food wastage, there is lack of transparency and too many intermediaries that are there. There is 100% scope of involvement of IoT as well as various other technologies in this entire value chain. Now, coming to the topic of today, what exactly is IoT? So the word actually stands for Internet of Things. So this is slightly more of a history lesson. If you go back like about 30 years, we had analog devices. So you had your radio communications, which are all analog devices. Slowly, digital communication and digital modes of electronics started to come into the market. Then you had the entire internet revolution that actually happened, where things could be shared using the World Wide Web to anybody in this world. Then it was actually the idea of like, can we actually start connecting devices to the internet? And one of the earliest use cases that actually began in the US was the use of RFID. Today in India, if you look at it, we have the toll nakas where you go, you have the easy pass that is available. That is nothing but when a car goes through it, it gets scanned, it gets fed into the system, and your banks get to know where you have gone through. The government toll guys know where you have traveled and traversed through. So the main thing is through a simple use of RFID, you are able to get connected to the internet. So that was one of the earliest use cases that was there. From there on, I mean, there is no limitations now. You have your reefer vans, your refrigerated vans that are continuously monitored for temperature. So which means our device is actually there physically on the vehicle. It is connected to the internet. It is connected either via Bluetooth. You can have various modes of communication, whether it is Bluetooth, whether it is Wi-Fi, whether it is GSM, GPRS based communications. So the aim of IoT is where a physical device is present, but how do you make it smart by getting it connected onto the internet so that folks in the stakeholder or the ecosystem can benefit out of it. As I was taking the example of Easy Pass, the beneficiaries are: one, as a customer, you can seamlessly travel from point A to point B without any physical stopping. Second, the amount gets deducted from your bank without actually need of any physical transaction. Third, the toll guys, whether it is the ministry NHAI or the Ministry of Roadways, they are able to compile a list of the traffic on the road, and they get to know various traffic loads on which parts of the highways and so on. So the entire ecosystem starts to benefit when there is IoT and Internet of Things. So this is a broad classification of what IoT is all about. It is nothing but where a simple device is connected to the internet and you can make a beautiful thing out of it, and the entire stakeholders and ecosystem can benefit. In terms of IoT and AI in the agri value chain, how does it actually disseminate? So let us start with the water and crop management part of it. This is where we can have actual resource quantification at the farm level by getting primary data from the farm. This is where GramworkX actually works. I'll be showing the tools and technologies that we have developed, so that I'll go into in depth about the water and crop management part of it. The second aspect is weed detection robots. Nowadays, you would have seen there are robots which follows kind of a line follower methodology and is able to detect what is the real crop versus what is a weed. It is connected all the time to the internet, and then it is sending live data from the robot onto the internet, and then interventions could actually happen. Third is drone-based pesticide spraying. Right now, it is in demand, except for some of the policy aspects in terms of how one can actually utilize this. But this is a great example of where a live device can be utilized on the farm, is connected to the GSM or the internet, and interventions could happen. For example, people are fitting hyperspectral cameras on this. It is able to scan your entire farm plot, and once it actually scans, it is able to provide which is the area of infestation or stress and appropriately take actions in that given area. The fourth aspect is actually pest detection. There are organizations which, with the help of a click of an image, is able to quantify what is the kind of pest or disease that your crop is having. This is an example of purely not coming into the IoT part, but like where you can say that the smartphone is kind of the link between the physical and the digital medium. In terms of crop quality detection, there are tools which is able to grade, again using image based detection through the phone or through certain cameras that are fit on trolleys. You are able to provide information about whether the grade is good or not good for a given type of a crop. Other methodologies which is using artificial intelligence, which is a one level ahead of IoT. It is using chatbots for farmer, so it provides specific information to the farmers to any issues that they would had. To like the demand prediction and forecasting that could happen on in terms of understanding what your market prices are, to the price prediction of the various mandis that are there. That is a broad overview of where IoT and AI could be utilized in the field of agri value chain. Come to the point of where GramworkX is actually working in this segmentation. I'll be going through the technology that we have developed, the problem statement that we are trying to focus, and how do we make technology that is made in India for the Indian farmers. This is one of the motivation that we have. So the problem that we are trying to tackle at GramworkX is about water. So water is a critical resource in agriculture, and the point to be raised or a red flag that we see is India is already a water stressed country. Now, at a macro level, when you look at it, India has only 4% of the world's freshwater resources. Out of this, 60% is utilized in agriculture. So you can actually see the amount of pressure that agriculture already has in terms of resource utilization, especially towards water. Also, if you see over the last one decade, there has been a 20% reduction in the per capita water availability. So these are some staggering statistics, and data doesn't lie. So these are all some statistics which kind of makes us go to the point where India is a water stressed country. At a micro level, if you look at it, 60% of the farmers are struggling with weather uncertainties, especially erratic rainfall. Now, these are some numbers that we have come out across our own primary survey that we conducted with about 160 farmers in the regions of Karnataka, Andhra Pradesh, Telangana, Tamil Nadu, and Maharashtra. Out of these 60%, close to 80%, so you can say a majority of them, have lack of database decision support systems, especially towards irrigation. There is lack of data in terms of taking a decision. So either they utilize rudimentary methods of touch or feel, or it is the ancestral method of utilization. So how do we enable decision based on data? So there is a lack of this methodology that is there in the Indian agricultural context. Also, the overall ecosystem, we saw there is high water exploitation, especially groundwater resources, and it exceeds the replenishment. So all of this makes India a water stressed country. Now, just by knowing all these figures and statistics, it is of no use unless and until there are interventions made. At GramworX, aim and motivation is how do we intervene using technology at the core of it. So let us look at what do we do at GramworX. So the first thing is we are monitoring. So this is where the entire IoT comes into picture. We have developed a made in India device. You can almost call it as a smart weather station, which is able to monitor various farm parameters all the way from temperature, pressure, humidity, rain bucket, wind speed, and all of this is connected via a solar panel. So it is a remote station and then is sending data to a cloud on a real-time basis. We are also using certain standards such as the world meteorological standards. So we are up to certain, the data that is collected is of the highest quality. Now, when this information is actually collected from the farm, your primary data actually becomes very, very good. So this is where the IoT device is of utmost importance because you're getting very, very good primary data from the farm, from a given farmer's land. Information is going to the cloud. We use communications such as GSM, GPRS. So you can almost think that you have your phone, and the way the phone communicates to a tower is using a GSM module. So similarly, we have the entire module built in it. So it is taking all these real-time parameters from the farm, taking it onto this module, and through the GSM, we are sending it to the cloud or the backend, as we call it in technical terms. Now, when we take this data and it comes to our backend, this is where we are actually using some algorithms such as the soil water balance method, using certain methodologies such as evapotranspiration, where based on the geographical location from this data is coming, the soil type on which it is actually situated, uh, and on the real-time parameters that we are getting, we are able to compute what is the soil water loss. So we are actually able to tell the farmer whether you need to irrigate today or not based on scientific data, but it has all been inputted and done in our backend. The second thing is in terms of analysis, we are also able to provide various algorithms based on the disease management. So if we get to know certain climatic conditions are crossing certain thresholds, we are able to tell the farmer that, hey, there is a higher probability of bacterial wilt, or there is a higher probability of a certain type of virus that could be coming for your crop. How is it provided to the end customer? It is provided using a very simple digital platform. Right now, it is on Android Play Store. So a farmer has to just input key information such as, say, what is the soil type, what is the crop growing, and when has he actually put the crop for sowing. Once he inputs this, on a daily basis, he is getting information whether he needs to irrigate or not, whether there is a higher chance of disease probability. And also, we have added an additional layer of satellite data integrated onto it. So, which means data such as NDVI, EVI, which actually tells that there is a given stress in your land. All of this is provided to the farmer at the palm of his hand. So these are the three verticals in terms of technological interventions that we are working at GramworX. So the overall benefits in terms of using this IoT device and this entire database decision support management tools are: one, is able to get real-time weather conditions from his farm. He is able to add multiple crops. He is able to get irrigation requirements crop specific. He is able to get crop advisory as well as disease management. We also have enabled what we call it as artificial intelligence in irrigation management. So he's able to get 1 week advance of irrigation planning. And there are certain other features such as connection to the digital market. And all of this is available in multiple languages. So there is Hindi, English, Tamil, Telugu, Gujarati, Kannada, Tamil. So close to seven Indian vernacular languages are covered in this. Now, I'll just quickly go through the product overview, what we have. So we have the GWX100, which is the IoT device for open field cultivation. This is where you have all the features such as temperature, pressure, humidity, wind speed, solar panel, as you saw in that earlier image, and I'll be showing you some more image. where all this is getting collected from the farm. So we have great primary data and then is being sent to the cloud. We have GWX50, which is for the polyhouse or for protected cultivation, as well as we have the Vajra series, which is for automatically turning off your pump from anywhere you are. So we are one of the first to be utilizing a technology based on MQTT, where we are having real-time insights on where your pump is located, whether it is having any kind of fluctuations in the RYB voltage. You can automatically turn on your phone from the same app that I showcased to you. In terms of the services, because what we need to showcase to the farmers or the farmer producing organization is ease of use. So we have a very simple tool, an application where they're getting all this information. So they get location based weather information. So that is coming from the IoT device. They're getting irrigation quantification. So once we are able to get the good primary data, we send it to the cloud, and the farmer only is able to get irrigation quantification. So we do irrigation quantification based on if he's doing flood irrigation, we tell him how many liters of water to irrigate. If he's doing drip irrigation, we tell him per plant what is the water utilization. So we are going to that level of micro information that can be provided to the farmer. Today, when we talk of drip irrigation, the aim is to get more crop by using with using less drop. Our intention is how do we have more crop, but by using quantified amount of irrigation. Then there are other features such as satellite data, crop advisory, pest management guidance, expense management, and then linking to the business dashboard or to the FPOs. These are some of the benefits to the farmers and the entire ecosystem. So by using precision technology, there is an increased yield by about 20 to 30%. There is also an increased revenue cycle because of an improvement in the yield of productivity by this number. And there is also reduction in the labor utilization because you have everything at the palm of your hand. You can try and utilize some of these interventions. In terms of the business, or an FPO is what we kind of consider the business, they are able to get organizational transparency, real-time information to and fro from the farmers, as well as marketplace linkages. Since the topic today was about IoT and irrigation, these are some images of about our IoT device. So you can see we have utilized some world quality and world standards in terms of the sensors that are being utilized. This is a rain bucket. This is a wind speed sensor. Then we have temperature, humidity, pressure shield. We have soil moisture. We have soil temperature, soil flux that is connected to it. So these are some of the sensors that are actually integrated onto this module, and it is sending us real-time data from the farmland almost on an hourly basis. So we are getting some very, very good primary data. So this is where IoT in the field of agriculture is kind of enabling in terms of quality data from the farm. We do have weather stations that are put by IMD and certain other private institutions as well. However, the resolution of that data is kind of poor. So you have a district, by the time that data is actually interpreted and comes to a farm level, there is a lot of distortion in that data. Hence, one to actually believe in that data goes down. One of the ways to actually help people to believe in the data that you're getting is by establishing these kind of systems at a farm level. I know cost is the most important factor, but with the function of time, some of these technologies are going to be very, very affordable. Also, the boundary conditions that we work on some of these technologies are like close to 60 to 80 acres. So such modules can be also shared by a group of farmers if they are growing a certain variety of crop in a given region. Now I'll try to go into some of the case studies that we have been doing. So these are some practical implementations that GramworkX has actually done. And it is just to prove that how data is kind of important in terms of taking a decision at the end of the day. So let me start with a case study of a slightly high level analysis that we did. This was a 1 acre of tomato, same variety in two different locations, one in Andhra Pradesh and in Maharashtra. So what we noted was the average temperature in Andhra Pradesh is consistently higher compared to Maharashtra. So you can see the blue line is always, if you were to even average these numbers, it is coming out higher compared to Maharashtra. So, a layman or in general, if one has to look at this data, you would consider that with a higher temperature, utilization or consumption would be higher in Andhra Pradesh compared to Maharashtra. However, what we saw that it was exactly the inverse. We saw that the amount of water utilization in Maharashtra was higher compared to Andhra Pradesh, and this was based on the algorithms that we worked on. And this is because what we saw that wind speed was consistently higher in Maharashtra compared to Andhra Pradesh. Now, when we look at certain algorithms that we built for irrigation management, wind speed plays a very crucial role in terms of not only the water content that is there in the atmosphere, but how it is being utilized for agriculture and especially for irrigation. So what net happened was the water utilization for Maharashtra net was higher in terms of requirement compared to in terms of Andhra Pradesh. Now let us go to some deep dive use cases of working with farmer groups. So this is a situation, or we are still working with a tomato FPO in outskirts of Bangalore, in a place called as Chintamani. So this Kolar region is very well known for tomatoes, or it is one of the tomato hubs in India. What we saw that they were not using any kind of data in terms of quantification of what they use on the farm. So they just buy the seeds, they sow it using the bed system. So you have the row and the space. Then they kind of get it from the nursery. And in terms of technology, yes, they're using mulching sheets are being utilized. Those are some of the things that are being seen in the Indian ecosystem. But in terms of actually taking data and how do you make any decisions on the farm, that was not being done. Also, in terms of the pest and disease indicators or management, they were not relying anything. They used to see what was happening on their field, and then it used to be all reactive decisions. Now, this is where we were able to set up this device for them. We have the Ramaswamy, who's the farmer, and also some of his farmer members in that area. So they are able to get inputs from us daily on what is the water requirement that is needed for the tomato plant on a daily basis. So they not only are they able to get the overall, but they're getting plant specific. They're given like the row to row spacing as 40 centimeter by 40 centimeter. So they are able to get plant specific water requirements for their crop. Second is they are also able to get certain disease management. So for example, this is where we had told them on 17th March that there's a higher probability of fusarium wilt. Now, not only we just tell them that, hey, there is a higher probability of this, but if you were to click on this, it also gives images of what are the symptoms of the fusarium wilt, as well as what are the preventive actions that they need in terms of the chemicals that they need to utilize. So what it is helping in terms of the IoT module is getting very good primary data from the farm level, so that interventions such as database decision support systems could be taken by the farmers or a group of farmers in this case. The second use case that we will talk about is in terms of working with a grapes farmer. So this is where the situation was, it's in a drought prone region. Irrigation was again based on touch and feel. So they used to have a farm manager and the farm laborers going around, and they used to just turn on the pump for 2 hours every day without really understanding what their requirements were. Third was it was a large acreage. So like any time, you have 15 acres and more, you realize your water consumption really goes up if you're trying to keep the entire area, under cultivation. So your bore levels go down, your bore dries up, you have to put, more resources into either digging it deeper, or in this case, they were even asking for tankers on a daily basis. So for a single tanker, they used to pay close to 600 rupees, and they used to have tankers come into their thing and fill it on the in the bund. Also, we found that there is a disconnect between the farm manager and the on-ground resources. So, what image that you see is the IoT device that is there, as well as, the data that we are providing. One of the data parameters that we are providing using satellite data. So what you are able to see here is the vegetation index or NDVI for various dates. So it is able to tell you for like a given cycle that you're having, which are the areas that are under stress. So you can precisely deep dive into that given region and then get an understanding of what is the issue. So not only are we providing him crop specific, or in this case grape specific water requirement, but at a high level, at a farm level, we are also trying to tell him, hey, where are the challenges in his zones or his plot of lands that he is growing. So the overall impact in this case is they have been able to reduce 40% of irrigation. And these are numbers that we have been quantifying based on what he used to use and what he is using right now without any effect to the crop on the ground. Second point is all of this is taking one step closer towards data-based irrigation management. We are also enabling them using, a dashboard for 50 plus acres. And apart from other things that I mentioned for the tomato farmer, we are also giving him satellite-based monitoring, so he's able to understand his entire plot as a whole. So this is in case of the grapes farmer. The third use case, how a simple device is actually enabling IoT and is transforming FPO. So here the situation was the FPO has close to 1,000 plus farmers. They use a manual process for invoicing. So most of the people have the pink book or the khata book, or in these cases, they used to just use a notebook actually. They used to also have lack of customer tracking. Just imagine if you're writing in this book on a daily basis, and this FPO is, reasonably doing well, and they have been active for the last 4 years. But there has been no digitization that has happened. So there was no tracking in terms of digitization. So they used to just run it. So, even as an FPO, it's a private entity. You want to have year on year growth. You want to improve your businesses. You want to understand which are the areas where you are actually lacking areas of improvement and so on, right? So digitization actually helps to bring about that transformation. They also had a disconnect between the farmers and the FPO board of directors. So, many a times you have heard that the FPO members and the FPO BOD, the active to inactive members are almost equal. And there is a big gap between these two layers, the FPO, folks who are in terms of the board of directors and the active members who are there. So this is where we have digitized their entire FPO. So not only the farmers are they able to get the app that is there, but this person who you can see using our tool, he has got a Bluetooth printer. So the Bluetooth printer is connected to our phone. And he is able to put all inventories that he is able to purchase from the farmer, and then he is selling to the trader. So suppose the farmer comes in the morning, he is actually selling his produce to the FPO. He has to just input certain things like name, quantity. The grade is then inputted, mutually decided between these two parties. Then they are able to provide the rate is negotiated, and then it is inputted. They are also able to take some images of the produce that the farmer is selling. And then he can just click on a print invoice, and the farmer is able to get an invoice of the produce that he has sold to the FPO, and the FPO has got a digital copy of that invoice in its ecosystem. Now the FPO is then selling these materials to traders in various parts of India. So it is able to track to whom they are able to sell. In terms of the IoT intervention that is coming here is by using a simple communication module of Bluetooth, he is able to print that invoice onto the farmer, and the farmer is also having a receipt in his hand. So earlier on, he used to have just a pink receipt and there was no digitization, but now he's getting an electronic receipt of what he has sold. And for the FPO side, not only can the FPO go and print anywhere, but the FPO, when it is looking at its finances or, how it is progressing at the end of the month, it is able to track, which are the customers that it has purchased from. So it is able to do some great insights into its own performance, how various things are functioning. There are a lot of features in terms of the FPO digitization that we have actually done. So if people are interested to know more about this, we can have a one-on-one session, or we can deep dive post this meeting. So the impact in this case is where more than 200 plus farmers have been digitized, more are in progress. There is a digital tracking of the crops that is grown by different farmers. There is a digital invoicing, sales and purchases. And finally, there is a digital tracking and analytics on the inventory. So they are even able to track what is their wastage. So they are able to quantify all of this at the end of the day. So coming to what do we aim at GramworkX? So the aim at GramworkX is to bring about accurate data and decision support systems to plan various activities. Now, all of this information is specific to the farmer, farm location, crop type, soil type, and available in a local vernacular language. In terms of technology, right? Because our entire topic here was about IoT and technological interventions. These are some of the challenges also that are there with technology as a whole. One is there is a large quantity of data that is needed. Not only large quantity of data is needed, but good quality of data is needed. So, through the help of Manage and other institutes, we are also working with organizations such as IMD and ISRO, where we have been looking at the last 40 years of historical climatic data from India and for the agroclimatic zone number 9 and 10. Where we have been trying to understand, how has been the weather patterns. Now, when we got the data is good, but there is a lot of cleanup that needs to be done. Second is, as we go ahead, the data needs to be stored and more data is of utmost importance. I think the entire world is focusing on data as the new oil and it is of important need. But how do we start building great data sets? It is when IoT interventions such as how we have placed simple devices on the ground is sending good data onto the cloud. So this also is a challenge because you need large data. So how do you enable rapid expansion of the technology is a question. Second is quality of data needs to be good. I just touched upon this point because whenever you want to build artificial intelligence or machine learning or any tools of automation, the data quality needs to be good. Third is at currently when we talk about IoT devices and all in the Indian context, cost is high. If I'm sure the question would be is like, what is our cost of the IoT device? So the one that we put in the poly house is somewhere between 25,000 to 30,000 rupees. The one we have in open cultivation is somewhere between 40 to 50,000 rupees. So surely the question is, 80% of the farmers in India are small and medium farmers. How can they buy this technology? How will it help to intervene for their daily needs? So this is something that we are constantly working, but as a function of time all these technologies will come down. It is like a phone, how it was and now what is the cost. It has been consistently coming down. The fourth point is policy and governance. This is where our core mission that we have built is, the problem statement was water stressed country. India is a water stressed country, and we have built tools which is enabling irrigation management. But water is free of cost, unlike certain other countries such as Australia, Europe, and all, where they need to pay a dollar or a dime or for the gallon of water that they are using. Unfortunately, because of the situation, very difficult to kind of charge for water, and even there are certain thoughts that are happening in the direction, but very difficult to actually implement it on ground. So policy and governance challenges are also there in terms of implementing some of these technologies, which we are slowly getting traction in various parts of India. But if you were to look at from a scale point of view, there are still some challenges that are there. The last point in terms of technology is capacity building, because many a times habitual changing is the most toughest part in terms of utilization of technology. Farmers still believe in the rudimentary methods. They still believe in the touch and feel method. It is slowly changing. We see that 2017 onwards, there has been an exponential utilization of digital penetration that is happening in rural India. So, a phone is actually one of the great means of, technological interventions that is actually happening. But capacity building needs to be done as to, hey, how is this technology actually going to help you? How will it help you to not only enable database decision support systems, but also certain other tools like connecting you to the market, making the FPO more transparent in terms of how its organizational business are going on. So there is a lot of capacity building that needs to be done. There is work going on all these segments, but these are some of the challenges I thought about mentioning. This is my last point. There are endless opportunities in using IoT and AI for agriculture, but the value of any idea lies in the using of it. With this, I'd like to thank Manage for giving us this opportunity. At GramworkX, our aim is to provide more crop with less drop and better incomes to farmers by bringing predictability to farming. I will also share, the last point where you can contact us. Our email is hello@gramworks.com, or you can take down this number. We are happy to kind of share any information that we have been working on.
Thank you very much, Gopal, for informative and presentation. The new kind of a technology, latest technology, and IoT-based technologies might be kind of a new to many people, but to explain in a way that they would also would understand and to try to there are first and most important question. You yourself has told that it is cost close to 45 to 50,000 per device.
Right.
So what kind of plans you are making so that it can reach to small and marginal farmers? Typically, there are two ways other companies are doing it. One is on a custom hiring or rental basis.
Right.
Number two, mixing it with any of the government schemes or kind of a device, farm mechanization device. You know, a lot of government schemes are there. Have you
Right.
explored any options? Can you please elaborate on that?
Yeah. So in terms of the farm hiring, methodology that you mentioned, unfortunately, we have not tried that. And the primary crux is, unlike a tractor or any movable thing, this ideally the entire cropping season, because we want to get great data from your farm, it's kind of located in a given place or in a given position. One of the ways to reduce the cost is, because we have great boundary conditions of close to 80 to 60 to 80 acres, it can be shared with a group of farmers. So like some of the FPOs that we're working with, close to 12 farmers are growing the same type of crop. They are actually getting data from one device. So just, if you have to put a denominator of 10, roughly cost per farmer is 5,000 rupees. Uh, so it's a great way of actually propagating technology where the, one single device can be shared with a group of farmer. In terms of working with the government, I think that's where we would like to continue the process with Manage, and in terms of looking at new avenues where we could either demonstrate or get it to the farmer or various other organizations in this segment.
Okay. Thank you, Gopal. And one more question from our side. And you said lack of data is something, perennial issue in terms of advising. So you said you are collecting data from IMD and other people. So how you are going to solve the problem in the future? Because typically it takes some time to see the test and analysis. At least 1 2 years cycles you need to standardize many things. So how do you are differentiating one crop to other at this point of time? What are the crops you are working on? Can you please elaborate on that?
Sure. So one thing is we have been constantly interacting with various agricultural organizations from India. So like, for example, yours is one, then NBSS LUP, which almost has got all the soil types in India. We have been interacting with them. So we have gone to the depth of understanding what is the soil triangle. So based on, the soil triangle kind of encompasses all the different kind of soil that is there in the entire world. So, when we go to the farm, we are actually doing something called as a simple ribbon test. So we are able to quantify the type of soil that you are having. That is point number one in terms of soil quantification. Second is in terms of the crop. We mentioned about, I mentioned about evapotranspiration. So not only are we able to compute what is the reference evapotranspiration, but also by understanding the crop stage So whether it's an initial stage or if it is in the developmental stage, or whether it's close to post-developmental stage, depending on the stage, we are able to provide the crop evapotranspiration. So depending on the cycle of the crop, the farmer is actually able to the actual irrigation that is required. So that is now making it crop specific. In terms of the crops that we have done is, we have done a lot of horticultural crops. So we have tomato, potato, onion, cabbage, cauliflower, a lot of horticultural crops. Also, we have done standing or field crops. So we have cotton, maize already in our back end. So all of these have been factored in. Now, where do we get some of these, as we call it as, information is working with institutions like yours. We have also been working actively with the FAO, Food and Agri Organization of the United Nations, in terms of understanding what are all the algorithms that are out there. So how do we convert this bookish knowledge into actual practical usability? So we have been, doing that and taking some of that information. So one is soil, what I mentioned. Second is in terms of the crop that we have been able to do.
One more question, very pertinent question, because there are a lot of big players in the space, especially Fasal is there, Cropin is also doing, I do not know whether they're into advisory. So how you are different when compared to them, and how you are going to go forward in the market strategy? For the benefit of everybody, Fasal is one of the startups who has raised a lot of fund in this space, working on a similar thing. I don't know how similar it is, but they're also, I think, trying to solve the same problem. Can you please elaborate on that?
Yes, sir. So our main point of differentiation is we are made in India. Our hardware is developed in India. So we have, not only developed the entire aggregation module, unlike some of our competitors who have actually just white labeled certain hardware technologies which have been developed in countries outside India, got it to India, and then just done the, say, the application part of this, in terms of what it is showcasing. So we have, that's why in terms of our time to actually come to the market has been slightly more longer. But that's where our belief is, how do we develop great IoT products in India? So what you saw on the image, the images that I showcased to you, I can proudly say that the entire thing module, whether it is the fabrication, PCB development, everything has been done by us in-house in India. Second is in terms of the algorithms that we have been developing. We have completed certain provisional patents because we want to see how do we build quality technologies in India, not only for the Indian ecosystem, but for the world as a whole. So that is the second point where we have been focusing on R&D and also in terms of certain quality algorithms that have been built. The third part of differentiation is the forecasting. We have been studying the last 40 years of data in certain agroclimatic zones that I mentioned to you. And based on that, irrigation forecasting could be done to farmers in these locations, as well as the model is can be utilized in multiple other locations. So these are three main areas that I would consider, the areas of differentiation. But that said, I also believe that in an ecosystem like this, there needs to be healthy competition so that the overall ecosystem as a whole grows. And then we are able to provide great solutions to the stakeholders in this ecosystem. So I think those are the three main areas how we differentiate ourselves, and multiple things that we are building on a daily basis.
At first, there is one question: high-tech extension approaches for support big-level farmers, these type of things. How to support small and marginal farmers? Any low-cost IoT or innovative methods are available, or anything? Any low-cost IoT? Somebody bothered about small and marginal farmers, how really they can afford this type of technology like that. Mr. Gopal, anything you want to tell for this?
Yes. Yes, sir. So we also have the Vajra series, where the cost is somewhere about 4,000 to 6,000 rupees, where using that IoT device, you are connecting it to the pump. You might be having a single phase pump or a three-phase pump that is there. You have to just connect it, and using a simple interface from our app, you can actually tell when you can turn on the pump, when you can turn off the pump. In fact, I'm just trying to open my app here so that I can showcase it to you, or you can go to the Play Store and yourself see for it. But you know how it is done is irrigation. You need to answer two questions: when to irrigate and how much to irrigate. By using the slightly expensive device that I told you, you are able to answer both these things: when to irrigate, how much to irrigate. Using the simple IoT device where you are actually connecting to your pump, we will actually just provide you how much liters of water that you need to irrigate on a daily basis. So we'll tell you the quantum of water that is to be done, but the frequency we'll not be able to tell you. So that simple IoT tool, you can still utilize it. It is, you know, rough to 4,000 to 6,000 rupees, very much in demand. In fact, we are having issues on the production side because of this lockdown, where the PCB guys are not able to get it manufactured in the right time. But if you can just see, you know, you can just turn on your pump, turn off your pump. You can also get to know what is the power status on your pump. Power is there. You can also understand what is the current that is there. You can also understand whether the three phases RYB is good, or bad. So just imagine all of this is there at the palm of your hand. And we have used a totally different technology, never being replaced. Either people use an SMS-based technology or they use an IRS-based thing. We have connected this using MQTT, the first that anybody has done here in India. What it helps to do is to the farmer anywhere he is, he can just turn on his pump, he can turn off his pump. If he's turning on his pump and if the pump is not turning on, he gets to know the reason why it is not turning on. That is point number one. Second is just turning on the pump on off. I feel as a technology company, it is a dumb product. But a farmer can download our app, which is free of cost, and he can get to know what is the crop evapotranspiration on a daily basis. So with that, he can get exact quantum of water that is getting lost from his soil, so he can irrigate that much back to his land. So I would say that if somebody is interested in that low cost thing, that is something we are doing.
This is Dr. Siram from Pune. Sir, this is a very wonderful presentation, and the technologies from the IoT, and especially in Maharashtra, the crops like grape, pomegranate, which are having the problems of pests and diseases, very serious problems, and that too related with the climate.
Correct.
Another major problem is sugarcane is our very, say, cash crop in the areas where their assured irrigation is there. And there lot of water is wasted in the sugarcane.
Correct.
So for this, this can be a wonderful technology. This is like say grape and pomegranate and say irrigation in the sugarcane. The technology is used by FAO in Africa for controlling the diseases of bees, and it is working very nicely. Likewise, this is very wonderful and say honest effort by this Gopalakrishna's organization. Thank you.
Thank you, sir, for your words. And if you would like to kind of connect us with, say, some of the organizations that you're working at the grassroots level, we are open for, like, say, pilots and or like, say, showcasing. In fact, Nasik Narayangaon is something that we are already worked before, but and already some orders are coming from there. So where we are trying to actively kind of implement some of these technologies. But there are multiple other crops that we can look forward to kind of implementing. Sugarcane is something that we have not done before. So if there is some interesting synergies for that, looking forward to it.
Another question, Mr. Gopal, are you working in any specific state or area, or across the country you are working? Like, there is another question from Dr. Manas Ranjan Senapati. Whether you are working only particular area or across the country you are able to work, how it is like that?
Yeah. So, sir, I mean, right now, we are in Bangalore, so we are trying to cover western and southern states of India. But that said, we don't want to limit ourselves. In fact, even within India and outside of India, we are getting some orders for some of these things. So we are trying to make the entire thing a DIY or do it yourself. So everything is there in the box. All you need is a pole. and certain screws. So everything is sent from our side in the box. You can install it like within 2 hours. Then you can just scan the QR code that we'll be sending, and all the information is starts to populate. The second thing is, suppose you are using a laptop. You can even use a laptop to kind of log in into your farm. Everything is geo-fenced, so you get to know what your area is. So we don't want to limit ourselves to geography specific. Some of the challenges that sometimes comes is operational wise. Sometimes people want to come to their farm and see, hey, what is going on? Can you come visit? In some of those situations, we kind of do it on a case by case basis. But we don't want to be geography specific. The technology that we have built is made in India, made for the world.
When you say per device cost, that is good, but how much of an area per device can cover actually?
Yeah, so that's what. So if you first thing, before we ship out the device, we actually do a topography analysis of your land. So whether it is a plain topography or whether it is a hilly area and all of that. If it is a plain surface and a plain land, and once we do the soil testing, we understand the soil type. The boundary conditions are close to 60 to 80 acres. So which means one device is enough to understand the entire conditions for about 60 to 80 acres of land. The only one drawback is the soil moisture sensor that is there below the, in a given point. But that is something also we are working in the next cycle where we'll be having multiple soil moisture sensors connected to a single gateway. It is called as a hub and spoke model. But our boundary conditions are roughly about 60 to 80 acres if the topography is planar. If it is a hilly area, like say some of the grape farmers that we have done is slightly hilly area, then we recommend them to do 2 units, one on the top and one on the bottom. So we are able to understand what are the speeds, what is the wind speeds and the lower part of the valley versus the upper part of the valley and so on. So before we even ask the farmer for the money or everything, our policy is use the device for 1 month for free. If you want, you ship it back, no worries. Second is we'll do your entire topography analysis, how the land is, how the entire, the modularity is. And we will recommend to you, hey, whether you need the 2 device, 1 device or not. Third, we have also done in certain cases where the data that we are getting from IMD is of great quality. All we have to do is put a soil moisture sensor in that location. So in that case, we have told the farmer, don't buy other sensors. The cost can get greatly reduced. You only put soil moisture sensor. That cost is only about 6,000 to 8,000 rupees. So we have kind of integrated data from the IMD that we are getting and the soil moisture sensor that we are getting from his farm to answer those two things: when to irrigate, how much to irrigate. So boundary conditions are 60 to 80 acres, but we do it on a case-to-case basis.
So effectively per acre, even if you average case also, it will come down to 1,000 or 2,000 per acre, you are telling.
Exactly.
Okay, so that is the message you need to drive basically, because if you see most of the device in the market probably would cover 1 to 3 acres, not more than that. So when you put 50,000 as a figure, probably you need to rearrange or selling strategy. Of course, would have been doing that. Should pitch in such a way that 1,000 rupees per acre per annum kind of a thing. So what is before we move, one last and most important question. So I have done studies on the durability of the product, how long it would last. When any maintenance costs are there, can you please explain that?
Yeah, so in terms of the reliability, it's always a concern. Right now, whatever tests that we have done, we say that up to 3 years, there is no need of replacing anything. In fact, the first 1 year, we put it everything under warranty. So if there's anything, we will support you. We will send our own operational guys on the, onto the field, get everything repaired. But right now, till date, we have had like close to 98% of like things working in a reliable way. Overall, the life cycle of the product is somewhere 3 to 5 years. But we only tell a lower number, 3 years, so that we don't oversell and underperform. So those are in terms of the overall, the lifeline of the product. Apart from that, in terms of the overall reliability, in terms of what we have worked in the lab and things like that, there has been always improvements, and we have already done a lot of tests in the lab so that when it actually goes to the farm, we don't have to send it back and things like that. So all those things have been done. Second is we are also trying to get some tests and validations done by third-party organizations who can put a stamp of approval in terms of the quality of the data that is being sent. So we are trying to compare it with Campbell Instruments. It's one of the best a company that actually sends it's into weather stations. So we are trying to test our data with Campbell Instruments. So just to understand that data that we send versus that entire set costs 5.5 to 6 lakh rupees. Our system is 1/10 of that. So we are trying to study with that system how the quality of data looks and so on and so forth. So we are getting a stamp of approval in regard to that. But the aim, in that regard is how do you build technology in India for the world again? And it's a time-consuming thing because whenever you have a hardware product, there is a time cycle that is associated all the way from designing, building, conceptualization to getting it running, testing, and so on, to like its adoption in the market. So time is there, but that's where we are motivated to kind of build some of these things in India.
Thank you, Gopal. Thank you for your today's your presence and presentation, and all the best for your work. Thank you very much.
Thank you always, sir, for your support. Thank you. Thank you, Yuvraj, sir. Thank you.